All right, let's get started. Thanks a lot for coming. I really appreciate that you decided to join our session. I hope you have had a great lunch and use the session afterwards for a power nap. So stay with us till the very end. It's going to be a bit of a challenging talk for us because it turned out that both of our laptops are not supporting mirroring. So actually this one is blank. So I will share the screen with you. But we will do whatever it takes to deliver the best talk. Actually, I was talking with my wife just before the presentation, and I told her we have this very problem, and then she told me, all right, so you guys are going to deliver talk about testing, but you didn't test your presentation, so something is wrong. So the key point here is that you should test whatever you're about to deliver in the environment very similar to your production environment, and that's what this talk is going to be about. So we will talk about the Assertable Chaos Monkeys, and you will see what we mean on the way. But before we do it, let's all agree on the one simple fact, that the software is everywhere. It's on our personal computers with all the procrastination traps called social media. It's on in our handhelds with even more procrastination traps. It's everywhere around us, in our kitchen, in our living room, home automation, cool IoT projects, or even self-landing space rocket. And I guess most of it is actually written by us, developers. I hope everything. But since we are human beings, we all tend to do mistakes. And hopefully we learn from them. Just to quote one of the most famous computer scientists, Edgar Dijkstra, if debugging is a process of removing the bugs from your code, then programming must be a process to putting them in. And of course, we have several different ways to prevent from bugs giving us trouble and making our lives hard and bringing sleepless nights, whatever else. One of those is automated testing. And automated testing, well, going back to the bugs, I guess. Yeah, that's why I don't have my speaker's notes and it's kind of smooth. But anyway, so we have several different kinds of bugs. Like there are those scary ones. Like for example, the one which hit Tesla, which was not really a programming bug. It was an issue that the clearance of the car was a bit too close to the ground. So when you were driving on the highway, it could happen that you would put your car on fire, literally. There are those which are stressful ones, like for example one which caused some problems in a French airport, I think Orly, if my pronunciation is correct. They had the system for monitoring weather conditions and communicating with the pilots when the conditions are bad. And it was running on Windows 3.1. So they obviously had some problem, but they didn't have anyone around who could fix it on time, so it caused quite a lot of issues back then. And then there are those which are annoying, like the one which happened to a Swiss guy playing in casino in Austria. And he won $57 million, I think. But the casino said, no, it was a software bug, so we can offer you a free lunch and $100 voucher. That was it. So what we can do about those situations and how we can prevent from bugs making our lives harder? Obviously, one of those is automating testing. And the first thing when you think about automating testing, these are obviously unit tests. And these are very fast, to give you a lot of good support for your design, for very fast feedback. And obviously, we should write a lot of them, because as I said, that's the fastest feedback you can get. But there are some problems with them. Like you can probably see in this nice picture in the background, unit testing might not be a sufficient solution sometimes. One approach for unit testing is to use mocks, and this is great. It gives full isolation, so you just test your one component and the other stuff you have total control over. What I have seen from a lot of projects where I was a developer, people tend to abuse mocks, and people tend to use a lot of mocks, and they set a lot of expectations, and then at the end of the day, they actually test the expectations of the mocks rather than the real logic. And I can recall a few situations from my latest project where we did some refactoring, and all the tests all of a sudden were red. which I think it's a bit contradicting to the idea of refactoring, because unit tests should probably capture behavior, not the internal implementation, and refactoring is changing the internals without changing the expected behavior. What we can do about it when we talk about unit tests? We can also use social tests. Social tests mean that we still use mocks somewhere around the third parties, which we don't have a full control over, but we also try to wire together more components so that they actually interact with each other. And this is great, but it gives few disadvantages. For example, it actually can result with very excessive boilerplate bootstrapping code, or it actually can also hide some integration things which you won't be able to cover by those. So I guess we also should ask ourselves a question before we hit to the production, like we did with our presentation today. Will it work in production? Are we sure that with the tests we have written, everything will work wired together when we deploy it? Will application run as fast as we would like to? Will users be happy about our user interface and so on? You can have in mind the so-called testing pyramid, which kind of sets priorities and amounts of the tests you should write on each and every level. Personally, I don't think that that's the best solution to apply. I would rather think about some sort of a scale where you think about what's the most risky layer of your application. So if it's mainly business logic algorithm, let's say, then obviously you should have the biggest amount of unit tests. If, on the other hand, you interact more with third-party services, then probably integration tests are those which you should focus on. If your UI is the crucial one and you need to provide support for, God forbid, IE7 or IE8, then maybe UI tests, which are not the fastest one, obviously, but they should be a focus. And what we believe in is that together with unit tests, you should also have high-level tests which are run in the environment which is close to the production, and we will show you during this presentation a bunch of tools or a universe of tools we have which can help you writing those quite easily.
So welcome to the Arquillian universe. How many of you know what Arquillian is? A few, good. So Arquillian is defined to be a middleware for your tests. It's not a testing framework per se. It's just something that sits in the middle between your test framework and your production-like environment and kind of handles all the interactions to remove the complexity for you of things like starting and stopping containers or deployments or doing those type of grunt work to get your environment, the test environment, up and running. So it tries to fill the gap between the unit test and the integration test. So integration tests kind of normally looked upon as a very semi-manual, hard, complex setups and completely different frameworks normally. Well, a unit test is a fast and easy thing to run. So Arquillian tries to be integrated with the unit test frameworks, but provide you with all the kind of different test-related services and management of your back-end services and servers and etc. And it's trying to reduce the integration test level down to child's play, essentially, to allow you to run the same type of unit test style from the IDE, from the build tool, and not have to be bogged down by waiting for your application to build for half an hour before you can actually deploy it somewhere. Be able to sit in the same tools and your same IDEs and kind of have the same programming flow as you normally do. And it's not targeting, integration we define as fairly loose. It's anything that's not the unit, essentially. So if you want to call it integration, call it UI, call it acceptance test, or whatever. Arquillian doesn't really care. All it does is to manage the middleware, or be the middleware for your test suite, and manage those type of test-related services or production-like services for you. It originally came out of the Java EE kind of environment with the containers, the application servers, so managing those application servers, deploying to them. and then allowing you to test what's been deployed. But we're moving beyond the Java EE space as well. And of course, it's an open source Apache 2 type of framework. So just to kind of go through a few of the steps, this is how you would start to use Arquillian. This is the Gradle example, but it works with Maven and Ant plus IB and so on as well. You start out by defining the dependency management section to kind of import a unified view of the Arquillian world with all the extensions and so on. And then you add which type of framework that you want to work with, that being JUnit, TestNG, Cucumber, Spock, or a bunch of other different versions of them. And then something that can communicate and operate on the production-like environment that you want to test against. This example, we're just assuming there's going to be a Tommy server running somewhere, so we're going to connect and use that as our environment. So looking at the JUnit integration, how the test case would actually look, simply relying on the extension point that JUnit provides, which is the run with, handing over the execution control of the test case to Arquillian. And then there's the deployment method that defines the target environment where this test is going to run. In this case, we're creating a web archive and adding a few classes and resources to it, all from the local class path, kind of bypassing the build system per se and relying on the incremental compilation and so on that exists in most of the modern IDEs these days. And that could be classes, it could be XML files, descriptors, libraries, and whatever else you need to add to create this test environment for you. Being a Java archive, a web archive, a enterprise archive, a resource adapter, and all of the type of standard Java EE deployment. But it could also be generic archives or just something else that whatever the container can support can be. And from there on, you write the test case as you normally would write a test case. You have the JUnit test method. And an added bonus here is since Arquillian knows where this thing is being deployed, and it knows which server it is, and it knows the deployment and so on, it can eject back to you the URL where this thing is actually being located, and you can avoid having to define all the property files and all for the different environments. So moving between your local test, your test environment, your staging, and potentially your production environment doesn't have to change the URLs in some form of property format. And in this case, we're just using the REST assured framework to do some assertions on a REST.
Two things about the deployment method here. So first thing is we say it's not testable, which actually means that we deploy the archive as it is. The other mode is that we add some additional things from Arquillian so that the test can actually be run in the target container itself. Here, since we are doing a black box testing and we just exercise the REST API using REST assured, we don't care about it, so we just deploy the war untouched. And in addition, I mean, the shrink wrap Fluent API is quite a good chance for you also to think about your modularity or how much of the coupling you have around your components. But it's not the only way. You can also just grab the arbitrary archive or grab it through Maven or, I think, Gradle resolver, which works pretty good when you want to, for example, test your application in the browser. Then you don't need to write all this bundling all together because that might be quite excessive. So it's not the only way, even though for integration component testing, I think it's a very good tool to think how granular is your module. And yeah, the principles of Arquillian. So if you recall the previous test, there was no notion about the target container in the test code itself. It only relies on the configuration, and the test, therefore, is portable. So if we would have several different configurations, we could actually run the same application in all the different containers or environments which support our programming model. Let it be JAX-RS with CDI or whatever else. You don't have any configuration code in the test itself, which makes it very good for for example, migration projects where you probably would like to migrate from EAP6 to EAP7 or from one container to the other, let's say. So the only thing you need to do is to provide the container adapter for Arquillian and probably just additional config file, and that's it. And then you can see if everything works as it should, assuming that your tests are good enough, obviously. So tests are portable. Our goal was that it can be executed like a regular unit test. So for example, Ctrl-Alt-Shift-XT from Eclipse or Ctrl-Shift-F10 from IDEA, and from the build tool. And in both cases, Arquillian will take care of all the plumbing and heavy lifting. Then, of course, we don't focus on reinventing the wheel. We don't write yet another testing framework. We just provide you an integration platform or the testing middleware. So we reuse what's the best around from JVM ecosystem. And as we said, it's also flexible to adapt to the new technologies, as we will see in the following demos and examples. And we can, even though it started with containers in the sense of Java EE, as Aslak already mentioned, it's also extensible to the new platforms. And the deployment is simplified significantly. Yeah.
So I assume as well everyone knows what Docker is.
Or is there anyone who doesn't?
Right?
That's good.
No, good.
So we can skip.
So we just throw that now. So, well, generally everyone knows that there's a Docker host, there's a Docker registry, there's a Docker image, and there's a container, and those start. Yeah, keep that. So, Cube, Arquillian Cube. That's the Arquilian extension that deals with Docker things. It's not necessarily Docker with a big D, but it's Docker images, Docker containers. So it might be OpenShift, it might be the Docker host local or Docker machine or any of those. What it does is to manage the lifecycle of the target platform again, but also including potentially building those images for you based on a similar concept as the deployment, where you can kind of run time or test time, I guess, add whatever things you want to that want to that image, and customize to make it a more test-friendly image potentially. So you can still do in-container testing in a Docker image, even though it's technically immutable, etc. So from a point of view of testing against Java EE containers that are bundled up in a Docker container, then you can use the normal Arquillian remote adapters to kind of connect to the container that is inside the Docker image, the Docker container that is started, and it works the same way. Our Cube just handles all the IP changes and the port forwarding and the starting and stopping of the containers. And it also, of course, allows you to orchestrate the different containers. So you can have multiple containers that depend on each other and so on. So kind of like a DrCompose, or essentially the same as DrCompose, but it's not just one single server or container. So that kind of moves us from being a integration or a component type of library to a more of a server system level testing, when you can control all the different containers, when you can control the database, you can control the front end, the back end, mail server, or whatever type of service you have. And yeah, with that, it also supports the notion of not containers, meaning not Java EE type servlet containers that are in a container, but just any Docker container. And it supports, of course, the Docker machine as well. So then, similar as the other one, let's go through the configuration. The only thing you need to add is the Arquillian Cube Docker, or potentially Arquillian Cube OpenShift, to have the OpenShift integration. And in the Arquillian XML, you can define, for instance, if you want to use the Docker machine, you just define the machine name, and you can say, so Cube kind of came out before DrCompose existed in a fully functional version. So there is the Cube format, which looks kind of similar to how DrCompose is, but we also support the full DrCompose format. So you can define the format to be compose and just provide a compose file. And then you qualify the container is saying that what's running inside one of these images is actually a Tomcat instance. So now we can connect to the Tomcat instance as if it was running on our local machine. The DrCompose file is fairly simple, or standard DrCompose, both version 1 and version 2. And from a testing perspective again, this looks pretty much exactly the same as the test that you saw before. In this case, we're starting up essentially a Tomcat instance in a Docker image and deploying to that Docker image as if it's a normal app server just happened to be running in Docker. But we have interesting things. So instead of just having a a URL to the deployment, you can also start to get access to the host IP where this Docker container is running. It could be when you talk about the Docker machines and Docker a swarm and so on, it will be the IP which you can reach this container on. And of course, you can also inject potentially the different port mappings and so on, and just start to call on that URL in the same fashion.
All right, so now the real test. Right. Let's see. All right, so that's the one, I guess. Yeah.
Yeah.
So we prepared the watch on the Docker PS just to show that we are not lying. And the test is very simple, so I hope I will be able to switch quickly that you can see.
Not that one, by the way.
Not that one. No, it's this one.
That's the container object one.
All right, that's not this one. All right, then let me see. Yeah, right, that's the one. Sorry about that.
That's the one.
But I think we reached the limit of messing with demo guts. So it's gonna be smooth afterwards. All right, so we have this hello world server test, which is actually part of the functional test suite for the cube. And here we have a bunch of different ways of interacting with the cube. So we can just invoke some low-level commands. By the way, can you see the code in the back? Or should I switch to presentation mode? All right, it's good. OK, and if you have any questions, just raise your hands and we will ask interactively. So here we're going to run the test for the cube, running underneath, I guess, some simple Tomcat server. So let's see what's going to happen underneath. So yeah, we have Tomcat, and yeah, we just run the test suite with some simple interaction with the container itself, where we just, I think, executed some top or do some operations with copying the files and so on. Yeah. But as you can see, it's super fast. I mean, this is not really what you would find useful in the sense of testing your apps. But for us, it's very important to verify that all our things are working good with the Docker client. And in the following demos, you're going to see more of the real-world examples. OK. So the other part is kind of a, I would say, unfortunate name. We still are open for pull requests with the better name for that. So we name it ContainerLess Container, where the second container is obviously a Docker container, whereas the containerless means it's not the container in the sense of application container, right? I mean, there's now a hype of serverless and all these things, so we were there before it even was coined. So what I will show here is containerless, which means that the test will run on any application that runs on Docker, any kind of application. So most of the cases, we will be talking about black box testing. So in this example, we will see some simple REST API. We have a bunch of the demos for that. For example, the one which I will show you shortly is running some Express.js application on Node.js. We also have some wildlife swarm examples and Vertex, Spring Boot probably as well. We will be using string wrap, so this Fluent API we have seen for building a war before, we will use it for building the Docker file. And yeah, that's again a simple configuration. We use Gradle for this because we learned from previous presentations that Maven snippets are not fitting to the slide, so that's a bit more concise. But essentially it's the same. All right, so that's our Node.js test. So what we are doing here, we create a generic archive, which is essentially a tar, and we just have our main application, so index.js and the package.json, and then we will interact from the test, which we will show you in the demo. Here you see that we can actually inject the URL, so again, it's a portable test. So what we have here, we have a template for the Docker file, and the only distinction is this variable here. Other than that, it's just a regular Docker file. So what this method will produce will be substituted here, and this will be used as a Docker file to build the image and then to run the container, and so that our test will be able to interact with it. And then we have a DrCompose, which is fairly simple. It just shows where the Docker file sits. And then again, if you are using Docker machine, then you can easily enable it just through the simple XML Arquillian configuration. And then we say which container which we define in this DrCompose we want to use in the tests. Okay, so talking is cheap. Let's try to mess with demo guts again. All right, so I have here this demo. And now again, that's our simple Express app. So it's a very simplistic REST API, which just gives you an answer to the strongest beer in the world. I think it's still the valid one. It's a Scottish 67.5%. I don't know really how it tastes, but it must be quite overwhelming, let's say. Then we have our test, which is pretty much the same what we have seen on the slides. So we build the archive, we bundle our application, and then the test will, again, using REST assured, it will interact with the REST API we have. And then this is the Docker file we were talking about, where the result of the deployment method would be put on our class path, and then this will be replaced, and this will be the final Docker file, which we'll use for running the whole test suite. Okay, let's try to run this thing. So we have still watch on the Docker container. You will see two things showing up. The first one will be actually building the image itself. So that's where you can see npm install. So we are building the image now, and then the real one will show up with the application with this substituted Docker file. I hope it's not downloading the whole internet now, as we know Node and Maven and whatever else is known for.
You're online, right?
Yep, I am online. I do hope I am. I cannot see the, yeah, it looks like Wi-Fi is connected. Yeah. Any questions to fill the gap? Yeah, hopefully it didn't fail. Now you will see the second one bootstrapped with the real application underneath. Yay, finally.
Green bar.
And green bar. So the test was blazing fast. It's just the npm install, which takes ages. All right. So that was the ContainerLess demo. Pretty simple, but at least gives you a glimpse what you can do with your microservices or whatever else you're building. And then we have another interesting feature in Cube, which is container objects. If you're familiar with page objects pattern from Selenium, actually the idea is the same, so that you encapsulate the behavior, you provide the behavior to interact with the Docker container, and all the low-level commands are hidden within this page object, and then there is, of course, some configuration to wire all these things together. So it encapsulates operations and config, as I just mentioned, serves single responsibility. Now, I'm not sure if it doesn't contradict the first point a bit, but let's say it doesn't. And you can reuse it, so you can actually ship it as a jar, and then if you have several different projects which are relying on that, it's pretty easy to use across all the tests. So this is how it looks like. So we have our cube, which is the container we have, which we name ping pong, and this is the port mapping or binding. Then again, we can inject the host IP, like in the previous example we could. We can also have access to the port and the Docker client, which is our low-level entry or the gateway to the Docker container. And then you see that we are creating the Docker file, which is essentially a description of an image. And this one is pretty simple because we are just inheriting from some simple ping pong. But you can use shrink wrap to build your Docker file or the Docker descriptor using Fluent API. Might be more appealing than just typing all these commands by hand. And then we can get the connection URL or encapsulate any kind of other behavior. And then how to use it in the test, we can simply inject it. And then in the test itself, you can just ping the container and assert that some response was returned. So let's see in the demo how it looks like. I think it's this one is the right one, right? Okay, so that's the whole test. So as you can see, the ping, it's pretty much just opening the HTTP connection to it. Super simplified, but for the sake of the demo and for not messing with the demo gods, I guess we can all assume that it has some value. But I guess you can imagine that with this kind of concept, it opens a lot of different opportunities and a lot of cool functionalities you can build to interact with the Docker containers. Let's try to run that. All right, so this time it's blazing fast. No node involved, no Maven whatsoever. OK. And now to the coolest part. We have a lot of applications and services online, but it happens quite frequently that, for example, Twitter or GitHub is down and then everybody complains. So we need to be prepared for such a situation and monitor and promptly react to such outages. And there are several cool tools which came from, for example, Netflix and all the other companies which are suffering these issues. And we're going to present you one of those, which is part of the Arquillian Cube Q extension.
So for all the Star Trek fans out there, I'm sure you know what happens in any episode where Q pops up. Chaos emerges. There's never any order when he's around. So the Arcadian Cube Extension. In a simple setup, we have one service that calls some other service internally within the Docker host. And what we want to do is to give you control over what's happening between those calls. So you can play Q in your own production environment, essentially, create chaos. So that's a toxification process that the CubeQ extension provides. So what is Q? Q automatically intercepts and injects and changes your original DrCompose format to inject toxic proxies between all the different links. That means that anywhere in any service call, you can now control what's going to happen when that call actually occurs, and create chaos on the level of changing the network connection itself. So you can say it's down, you can just make it slow, you can make it not quite be able to behave as it should, either on the upstream or on the downstream path. And that should give you fairly nice control over see what your application actually do or how it should behave when the network becomes kind of hacky. We know that networks in general really don't work as we want them to, but from a setup perspective, you still have your normal DrCompose file. There's nothing Q in there at all. A queue just automatically reads up that format, understands the port bindings and so on, and just injects new containers in between. And the dependency is just CubeQ toxic, which relies on the toxic container. And from the test perspective, what's new here is that now you can inject the Q through the Arquillian injection. And with Q, you can say on a specific container, on a specific port, add some type of toxicity. So it means that when this call down here to the host, so let me recap. So our application here is binding a server on 8081 on the host. When that's invoked, that server will call on the ping pong service on 8080, which is internally in the Docker host in a different Docker container. So we're saying that when someone tries to call ping pong on 8080 during this block, then change the latency of that helper connection. And whatever we do within that block, we could do essentially whatever we want. So look at the demo, and we'll see some other examples as well. Before you start to run it, let me just go through the source code there a bit.
In the demo itself?
Yeah, in the test case.
Sure.
So we have a couple of different examples here. So the first one is just going to, can you not full screen it? Because it goes outside of, there we go.
Yeah, sorry about that.
So the first, bigger?
Bigger, okay. Let's try the toggle presentation mode. Oopsie. Okay. Better?
That's better. Okay, so the first section is for 15 seconds, and this block is going to continuously execute for 15 seconds. When that happens, well, the first one, we're just going to execute for 15 seconds. There's no toxicity thing happening. Then in the second 15 seconds, we're going to say that when something hits 8080, we're going to add a latency on the downstream pipe, essentially. And then on the next section, we're going to execute for 10 seconds, and then we're going to say that that pipe is down, so there's no connection to it. The front-end server can't communicate with the back-end at all. So what we've done in this demo is that the front-end server that is running on 8080, the one we're communicating with through the HTTP connection, has the Netflix Hystrix installed on it, so it will report it to the Hystrix console, so we can see the different connections happening and when it stops and so on. So if we run this test and we start the console, we should be able to see kind of that the network connection.
Just the one remark. If you have seen the studies of how the exceptions are used in Java, the checked exceptions, I guess this is the most common pattern, so we are compliant at least. Okay, so before we run the demo, I just make sure that I don't have any Docker leftovers. I don't, all right. So we have a breakpoint here so that we will have enough time to switch to Hystrix. And so that we can see how all these latencies and other toxic behaviors interact or influence the whole test suite. IDEA is rebuilding the workspace, apparently.
Yeah, why not?
Why not? Okay. So all the containers are up and running. So I switch to Hystrix, where I already have everything prepared. And I will continue with the test execution. So now you see a bit of graphs.
So now the connections are coming in, everything is fine. We're just going to be doing that for about 15 seconds. And then you'll see it start to get slower and slower, and as the latency starts to apply, which is happening about now, it seems. And you'll see the connection pointing and just drop down until it's just dead because we shut down the whole pipe.
And now the failure part came in.
Yeah, no, it's dead and down.
Yeah. Okay, now I guess the test is finished. Should be a pop-up from GNOME, but apparently it's not.
Yeah.
Let's see.
Might be shutting them down.
Yeah. Still shutting them down. Yeah. So as you can see, also Arquillian Cube takes care of spawning and stopping the containers afterwards. So everything is kind of self-contained. Yeah, green bar.
Green bar, awesome. So that gives you kind of a network level control of all the Docker, within your Docker host. That's just the first release of CubeQ. In the next one, we're adding more chaos-like things, so you have the container control as well. So you can kill the random containers that are running potentially more automated type of chaos events. So it will just kind of randomly do whatever, and you can still see that your application is up and running.
Okay, so to recap, as I said at the beginning, unit tests are very important and you should all write them. Important thing is to understand where is the proportion, what is the most important part of the system for you. And if it's more about integration and above, this is the right tool for you and all the extensions we have. As we all learned, and we in particular from the mirroring story, you should really test at some point in production-like environment, because this gives you confidence that if you deploy your stuff to production, it should work as you want to. We have a lot of extensions which we didn't show here because the focus was on Docker and toxicity, but we also have, for example, support with Byteman, which lets you do a bytecode injection, and then you can also test your components with some unexpected failures from within the code. So expect unexpected, as we all learned. That's very important to be prepared for that, and I believe those tools give you an opportunity to react on it before you will see all the complaints from the users on Twitter. And Arquillian, even though it started as a Java/Java-E integration platform, the goal for us is to build it as broad as you would love to. So give us feedback and tell us what's important for you, and we'll try to hack around. And we would like to leave you with this interesting quote that it is not necessary to change. Survival is not mandatory. Or in other words, you can still test manually. That's the outcome. I hope that was interesting for you. So now, since we delivered all the content, I guess we can introduce ourselves. So my name is Bartosz Majsak. I'm originally from Poland, living in Switzerland now, working for Atos Consulting. I've been contributing to Arquillian for the last 5 years, I guess, and I think I'm responsible for more bugs than features, but I built a few extensions. And you can follow me on Twitter if you like the talk, or if you didn't like it, it's even more necessary for me to hear about it. Just shout on Twitter, I'm around, and also on GitHub.
Yeah, I'm Aslak Knutsen. I'm the Arcadian project lead. It's been that for the last six or odd years. Currently a software engineer at Red Hat, and you will find me at Aslak Knutsen or on Twitter rather.
And we are not twins, right?
Huh?
We are not twins.
We're not twins, no.
All right.
We're just two white
These are the links. Yeah, and we drink beer together. Anyway, so these are the links. This is where the presentation is or will be in the final shape, because you always do these final changes just a few minutes before the talk. The most important part is the Arquillian.org and discussarquillian.org, and all the other things are on GitHub under Arquillian organization. We would like to thank Alex Soto, who is not here with us, but he's also part of the Arquillian team as a Red Hat engineer. He helped us a lot with the demos. So all the glory is for him, and all the failures are his fault. So that's it from us. We are open for questions, and enjoy the rest of the conference. Okay, first question. So the question is toxic proxy supporting only HTTP at this point?
No, it's whatever's running on the port. It doesn't care. As far as I know, yeah, it's just a port. So as far as the toxic so the question, we can repeat it. The question is it only HTTP that's supported between the different toxic or the containers that are being toxified? No, for the toxic proxy, it's just a socket, as far as I know. So whatever's on that socket, it just kills it. Yeah.
Okay. Next question. Okay. So the question is the latency the only failure we support? I think in the demo we also have a failure which just brings the server down.
Yeah,
any other ones?
You can have slow close on the connection. You can have the bandwidth can be adjusted. Latency, jittering on it. What's the other ones? Down and I'm sure I'm missing one.
Yeah, we can check in idea. But yeah, it's not only latency at least. Okay. Any other question? Next one from you. Could you repeat again? Yeah. All right. So the question is, we showed the DrCompose for orchestration. Is there a support for Kubernetes?
So yes and no. So CubeQ currently only works with Docker or Docker host, Docker machine, whatever. Docker with the big D, Docker. But Cube itself works with OpenShift 3 as well, which is Kubernetes based. Currently, that's bundled into the same thing. We're thinking about splitting the OpenShift 3 support out, so there's a pure Kubernetes version and an OpenShift 3 version. Now, Kubernetes on its own might not be able to support all the things that Cube does, since it's much more of a pure deployment thing than one more, with the builds, etc. that OpenShift 3 has.
Okay. So I guess that's it. Thanks a lot and have fun on the conference. Thank you.